welcome back. This is Math 1300, Nunez Community College. The section we'll be doing today is 7.1, and this is called General Equations. It kind of overlaps the last section a little bit, but there are several different types of questions. An equation, of course, has an equal sign, and we are trying to solve for a variable. These equations have one variable, so it's a linear equation. The first thing that we have is 3x minus 7 equals 5. The object here is to get x by itself on one side of the equal sign equal to a number. So again, like we talked about last time, in order to get the things away from the x, which is the 3 and the 7, we have to do the opposite of what we see. This says minus 7, so in order to get rid of it, we're going to add 7 to both sides. Sorry, minus 7, so we are going to add 7 to both sides. These cancel out, leaving me with 3x equals 5 plus 7 is 12. Now the 7 is gone from the left side. I now want to get rid of the 3. This 3x means 3 times x. In order to get rid of the 3, I do the opposite. The opposite of multiplication is division, but I have to divide by both sides. Cancel the 3's out. X equals 12 divided by 3, which is 4. So this is called a two-step equation where we have two things to do in order to achieve our goal, which is x equals a number. Example number 2. We have 5 equals 9. 5 equals 9 minus 2x. In this one, the x is on the right. But as we discussed in the last video, it does not matter if the x is on the right or the left, because x equals a number or a number equals x is the same thing. So with this one here, we're going to try to get the 9 to the other side. There is nothing in front of the 9, but it's a positive 9. So we'll treat it as a plus 9. In order to get rid of it, we're going to subtract 9 from both sides, canceling the 9's out. 5 minus 9 is going to be negative 4 equals negative 2x. Now we have negative 2x, meaning negative 2 times x. The opposite of multiply is divide. We're going to divide by what we see. So since it's a negative 2, we're going to divide by negative 2 on both sides. This not only cancels out the 2's, but it cancels out the negatives, leaving me with x on the right. Here I have negative 4 divided by negative 2. A negative, 2 negatives is a positive, so that would be what? Positive 2. X equals 2. Or 2 equals x. It's the same thing. Example number 3. Now we're dealing with fractions. 4/5 x minus 1/2 equals 3/4. In this problem here, of course, our objective is the same. It's to get x equal a number. But I don't really like dealing with fractions. I don't think very many people do. So what we have to do, or what we want to do, is we want to try to get the whole equation to where there's no fractions. In order to do that, I'm going to multiply this equation by the least common denominator. So I need to find the least common denominator between the 5, the 2, and the 4. So that means the smallest number that 5, 2, and 4 all go into evenly. That number would be 20. So 20 is my least common denominator, and 20 is what I'm going to multiply this whole equation, literally making it 20 times bigger. But in order to do, or by doing that, we're going to eliminate the fractions. So I'm going to multiply by 20 to each one of the terms. Okay, so 20 multiplied by each term. Now what we do is we can cancel since it's multiplied. 20 divided by 5 is 4. So we have 4 times 4, because this 4 is left. 4 times 4 gives me 16x. The x is multiplied also. Minus, here we can do 20 divided by 2, giving me 10. 10 times 1 is 10. And then we have 20 divided by 4 is 5. 5 times 3 is 15. But by multiplying the whole thing by 20 or raising it 20 times larger, we end up with no fraction. And once we end up with no fraction, we can solve from here. This is now the equation that we had in the first couple. We would take the 10, bring it to the other side. So I got 16x equals what? 25, because I'm adding 10 to both sides. And then I'm going to divide by 16, divide by 16, and I have x equals 25 over 16. We can keep it as an improper fraction. I think that the program wants us to leave it as an improper fraction. All right, moving on to example number 4. In this example, we don't have a fraction, but we have variables on both sides of the equal sign. I have 2x plus 3 equals 5x minus 9. In this one here, our objective is always remains the same. The variable equals a number, which means the variable needs to be on one side of the equal sign or the other. Here we have it on both sides. So I either need to bring the 5x to the left or bring the 2x to the right. My goal here, or my objective here that I always say is bring the smaller x to the larger x. Why? Because it keeps the x, or the variable, positive. So I'm going to bring the 2x to the 5x by subtracting 2x from both sides. To get rid of it, that takes that away, leaving me with 3 equals 5x minus 2x is 3x minus 9. But I've achieved putting my x on one side of the equal sign. Now my goal is the same. Take everything that's with that x and bring it to the other side. So I'm going to add 9 to both sides, giving me what? 12 equals 3x, because these two 9s are going to cancel out. And now I have what? 3 times x, so divide by 3, cancel them out. X equals 12 divided by 3, which is 4. Okay, example number 5. If you notice, everything is working exactly the same way. We're achieving isolating our variable and equal to a number. We're just adding stuff to it. We're literally adding fluff to it. But we're gonna have to do every step that it's gonna call for and to make sure that we achieve our goal. So I have 3x plus 4 minus 5x equals 2 minus 4x. Now in this one here, again, it's just more stuff. We're going to condense and do what we have to do in order to solve for x. So in this one here, I'm going to take these two, since they're both on the left side of the equal sign, and I'm going to combine them. That gives me 4 minus 2x. Negative 5x and plus 3x gives me a negative 2x equals 2 minus 4x. We've combined like terms. That's what we call it, combining like terms. Now we have exactly what we had last problem. We're going to either bring the 2x to the right or bring the 4x to the left. By the way, these are negative 2x and negative 4x. So if I want to bring the smaller to the larger, the negative 4x is the smaller. So I'm going to add 4x. I'm going to add 4x, canceling the x's, giving me 4 plus 2x equals 2. So now I've achieved putting my x on the left. Same process. Subtract the 4's from both sides, cancel them out. 2x equals negative 2, and divide by 2, and x equals negative 1. And finally, the most difficult, if you will, or the one that you have to do the most to, we're going to have 4 plus 5 times 2x minus 3 equals 3 times 4x minus 1. In this one here, the difference is we have these parentheses. What do we do with the parentheses? Well, with parentheses, if there's something on the outside, that means multiply by that number. When there's two things in the parentheses and one thing on the outside, we do something called distribute. We distribute multiplying the outside times the first term, and distribute multiplying the first term by the second. Same thing is going to happen here. I'm going to distribute to the first term and to the second term. This is going to be 4 plus 5 times 2 is 10x, and 5 times negative 3 is negative 15. Equals, over here we have 3 times 4x, which is 12x, and 3 times negative 1 is negative 3. Now we're going to look at the left side. I have numbers on the left, so I'm going to combine them, calling combine like terms. This is going to give me 10x minus 11, negative 15 and a 4 gives me 11, equals 12x minus 3. Bring the x's to one side, bring the smaller to the larger, so I'm going to bring the 10x to the other side, so I'm going to subtract 10x from both sides, canceling them out, giving me negative 11 equals 2x minus 3. Both things need to go to the left, so I'm going to add 3 to both sides, canceling that out. Negative 11 plus 3 gives me what? Negative 8 equals 2x. Divide by 2, and x equals negative 4. X equals negative 4. I found one more, so we're going to try to do one more. A little bonus for you. This one here has 3 times, in brackets, 2 minus 4 times 2x minus 1. Close your brackets, equals 4x minus 10. What are brackets? Brackets are nothing more than parentheses. But when I have parentheses inside of parentheses, we usually put the first parentheses as brackets. It just means the same thing. It's grouping symbols. So I could say that I need to multiply 3 and distribute it by everything. But when you're doing your order of operations, please excuse your dear Aunt Sally, the first thing that we have is parentheses. So that means we need to try to do what's in parentheses. So we're going to try to do what's in these parentheses. And we have operations to do in here. This is distributing. Distribute the 4 to the 2x and the 4 to the negative 1. So I have 3 bracket 2 minus negative 4 times 2 is negative 8x, negative 4 times negative 1 is plus 4. The rest of the equation stays the same. Now, within the parentheses / brackets, we still can combine. We have two numbers that we can put together, combine like terms. So that's 3 bracket 2 and 4 would be 6 minus 8x equals 4x minus 10. Now we are finished with what's inside the parentheses. So now we're going to go to multiplication, which is distributing. 3 times 6 is 18 minus 24x equals 4x minus 10. And now we're back to where we were. Bring the small x to the large x, and negative 24 is the small. So I'm going to add 24x to both sides. Canceling them, I have 18 equals 28x minus 10. Bring the numbers across, adding 10 to both sides. Canceling them out, 28 equals 28x. Divide by 28. And there we get x equals 1. Most of these simplify to a pretty number. So that concludes this section, which is section 7.1. I hope to see you at the next one. Thank you.